Is this a good font size for people? The 4chan logo. I don't know what the 4chan logo looks like. And tweeting the tweet. How do I change this default message that Twitch puts up when I start streaming? You know what I mean? Or when you tweet it out and it makes a link with a description? I need to figure that out. Taskbar can be put on the left. You have to install a third-party taskbar. Microsoft does not have the technology to put the taskbar on the left. Buy Twitch. Dude, I would not buy Twitch. Let me just say that. I would not buy Twitch. I was realizing that even if the next games do great and we make tons of money off them, which will be good, because then we could make more games, like I still won't even be able to afford one F-35 fighter jet, which like, I mean, I wouldn't buy one. I'd use it to make more games, but still, you gotta have perspective, right? Yeah. The camera on this laptop, I think, is pretty good. Usually, when I stream off a laptop, I use my old at this point, external webcam from Logitech, whatever model number, I don't remember. I don't see it. It's around here somewhere. Here it is. This one. But like, I feel like the built-in webcam is better than that now, or at least on par. Yeah, this is literally the camera built into the little dot on the laptop, which you would like. Again, this is a place where laptops have been trailing phones for a long time. Like phone cameras have been good. If I ever tried matcha ice cream, yes, it is not my favorite. Is the laptop screen 4K? It is higher than 4K. It is 4K-ish, but 16 by 10 aspect ratio. So one good life hack that I had was I just bought a bunch of Leathermans and have them laying around everywhere. And the problem with this is I don't yet have the muscle memory for any individual one. So for example, when I want to use the bottle opener, I need to figure out where it is. Also, this one, I guess it's not that bad, but like, where to use the bottle opener, where you want to put your hand, it's kind of precarious down here. There's like some semi-sharp pieces, but it did the job. Someday I may use this for real things, but that day is not today. The fact that people still sell laptops and 720p cameras. Yeah, well, they still sell laptops with 1080p screens that are glossy. Like they're finally getting over that. but that took most laptops out of consideration for me. It's like, I spend all day looking at text. I'm not going to do that in 720p on a glossy screen. It's just absurd. Or 1080p, sorry. 1080p. I mean, it sounds like a lot of P, but it really isn't. Okay, we should maybe get started soon. Yeah, we'll give people another 2 minutes to show up. Yeah, I don't know how much battery life this laptop has. Probably not very much when I'm running a game, to be honest. I'm going to switch over. Yep, okay. So, for those who have not been to one of these before, here is the deal. Let me just, okay, before I give an intro, let me just double check. Camera's good, lighting's good. I mean, it's not great, but it's fine. Okay. So, oh, how fast is the compile time? That's a good question. Let's do that before the thing. It may not have gone up by much. Let's see. I don't have my F7 programmed in yet, so I've got to go build x64. Oh, wait. No? Oh, it's in the wrong drive. Dude, so this laptop, they advertise it as 2 terabytes of SSD, and I'm like, great. That's what I want, because 1 terabyte isn't enough. It's got 2 separate M2 drives of 1 terabyte each. So I put Sokoban, because that's the big project, onto D, but now it's on a different drive than where I put the compiler. I should probably move the compiler too. But that's why my autocomplete was not completing. This might be cache. Oh, that's also LLVM being slow. That really took a lot longer than I wanted to, though. Okay. So for some reason that I don't understand, so the front end and x64 are faster. They're proportionally faster. They're not as fast as they were a long time ago, but I did some stuff that made the compiler slower that we have to go back and retrace. But so this, like if I were to run this on my other Razer laptop, this front end time would have been 1.5 probably. We should run it again just for cache effects. But like, look how long it's taking to link. Yeah, that's about the same time here. So 1.2 seconds, that's about right. But like the link is so slow. I don't understand. Like if I do the equivalent link over here, you can't see this. Ugh. Never mind, I can't do it because people keep fucking updating. Let me just try this. So locally, we shouldn't do this, but we have like modules for WYs and stuff as they're in the compiler module folder. So it doesn't stay in sync totally. Okay, so when I do the equivalent build on my older laptop, the front end timeline is 1.55, so this is a lot faster. The x64 is 0.17, so this is substantially faster, right? This compiler time, which is just this plus this, is 1.73 on the other machine. Now, link on the other machine is 0.49 seconds. And here it's 1.8. And I'm like, what? How does that make any sense? So I just hate linkers, guys. This is Windows Defender. I mean, I thought we turned it off, but maybe it turned itself back on. Oh, you know what? Guys, I didn't put the compiler in the exclusions, so that could be. Let's do. All right, we're starting the thing a little late. Wait, where's the there? So we're gonna go there, and we're gonna go just in case, because I never know how this works. Not that. All right, let's see if that matters at all. Probably not, but maybe, because it's probably linking the file. I don't know. I don't think it'll matter. Nope. Yeah, so the linker is very slow for some reason that we don't understand. Maybe it's Windows 11. Maybe there's something we can do about it. Yeah, x64 backend is a lot faster. Okay, so for people who haven't been to one of these before. Oh, by the way, one other good thing, I was just complaining about how the Razer trackpad on this laptop was stupid because it's way too big. They did do something good. I don't know how long that's been built in, but when you say function T, it turns the trackpad on and off like really fast, so you don't have to like go into some stupid menu somewhere. There should be a hardware button for it, but there isn't. But I'll take that. That's better. But you know, you wouldn't have to turn off the trackpad if it wasn't too damn big. Okay, so we'll finally start. What this is an opportunity for people who are in the closed beta for this programming language and compiler to just ask questions, and they could be long form questions, and we give long form answers, and we'll ignore Twitch chat for most of it, if not all of it, because it's about answering the questions from the elite private beta white glove club. So let me just pop over there, and we'll go. I don't know exactly how long this is going to go. You know, typically a couple hours. Maybe I'll get tired before that. Who can say? All right. So first question is, it seems that memcopy works well with overlapping ranges. How exactly is it implemented internally? The answer is I don't remember. And I'll put it this way. There's some decisions here that are a little bit questionable. So for history for people, memcopy, MEMCPY, was a function that you would use all the time in C, right? And it did not necessarily handle when the source and destination ranges of the copy overlap in the wrong way. For example, you know, the canonical time you would get a bad result out of memcopy is, you know, you have some source range that's like this, and the destination range, put it on the same line, the destination range like overlaps like that, because you start doing the copy left to right, and then you start laying down new bytes on top of the old ones, right? And then by the time you get here, yeah, either you understand this diagram or you don't. It's fine. I'm not going to spend a lot of time explaining it. But so then they made this function called memmove that doesn't have that problem because it detects whether the ranges overlap, right? And you could say, well, then why didn't you just fix memcopy to not have that behavior? And whenever you're designing a system, there's always concerns that you have, like maybe somebody relies on that functionality being, probably not, right? But that's always a concern that you have. And you might say, well, it's in the specification that you shouldn't care, but a lot of software written in C goes back to before there were specifications for any of this. And again, so one of the ways in which programmers used to be much more enlightened that they are not today is that programmers used to understand that the specification of the programming language, I don't know. I don't want to get into this rant again. I'd rather get to the rest of the questions, but there wasn't this whole idea of the specification of the programming language determines everything and only what you can do. There were it was understood that the language was designed with holes in it, and those holes were so that it could be mapped to hardware in different ways, right? And then your behavior depends in part on the holes, right? And so you wouldn't necessarily willy-nilly go changing behavior of something like this. So they made this new function called memmove. I don't like the name memmove because it sounds like you're moving something when you're copying something, right? So that they should have just been like memcopy2 or memcopy, whatever. But so when you make a new programming language, you always have these choices like how do I interact with these choices from the past? And I said, well, let's just use the name memcopy, which is weird, by the way, because I don't like abbreviations and it's an abbreviation. But I was like, let's just use that name, but we'll remove the problem. And so I at least put on the to-do list that I was going to deal with overlapping ranges. I guess I did that. When you work on a compiler like this for so long, you just do a lot of things and you forget because there's just a lot going on, right? Now, I was going to say the other concern why you might have wanted to maintain the old memcopy is for speed, right? Like if you know that your source and destination ranges don't overlap, which is true for almost every invocation of memcopy, right? Then you could not do a couple if statements, right? And that's true, but the thing is, you're going to have if statements anyway, depending on what's the size of the copy, because different things are efficient at different sizes, right? Or whatever. And also, if you very specifically know what you're doing in your program and you actually want maximum speed, you probably hand roll something because there's going to be something about your use case that the compiler doesn't know, almost always, right? So that can be a little bit of a red herring in a way. Anyway, how is it implemented internally? Well, again, I don't remember. We could go look for a second. So memcopy, memmove, and whatever the other one is, memset. I'm at this 2 different drives thing. Oh man, I gotta fix this. So these are defined as intrinsics up here in the preload. We used to have a bunch of intrinsics. Now we cut it down so there's only these. And intrinsic just means the compiler substitutes some implementation for this that it wants, right? And so the implementation depends on where you are. So if I go to, there's three different places right now, at least, where something can be implemented. What happens when you do a memcopy at compile time? What happens when you do one in each backend, right? So if I go here to so we have also internally 2 different memcopy instructions. If you know what size the copy is, often it'll be small, and you just replace that with a single instruction move or whatever, right? We don't actually do that here. That would be more a thing that you do. So here it certainly looks like we're just calling the libc memcopy. So it looks to me like this is actually not correct for overlapping ranges if you're running in compile time execution. So let me actually make a note there. Now, where did I put these files? No. I don't have anything like loaded or anything. All right. So here, when we get a memcopy, we're doing some stuff based on sizes. Yeah, it looks like we really are not doing anything special yet. So I think it's actually still on the to-do list to make sure this works with overlapping ranges. And I'm suspicious of your test that claims it works, right? But, okay. So the actual reason I haven't cared that much about this is as follows. Going back to this whole thing where these are defined as intrinsics, I kind of don't like that. Because again, you might have your own idea of how you want memcopy to happen. Certainly, of course, you could just call some other function instead of memcopy, right? But if you wanted to replace it for your whole program or something, this doesn't really let you do that. And so what I was going to do at some point is use inline assembly to just define these as just regular functions, and then you could, copy them and whatever. The reason I haven't done that yet, I always have hesitation about these things sometimes, like, okay, we make a function with some inline assembly probably, and then it's got these if statements that I'm talking about, and then we like inline it all over the place. And I just always worry what the impact of that is going to be on compile speed. And it also just hasn't been that high a priority, but sorry, long answer to simple question, I guess. Yeah, by the way, in the x64 back, so what it might be is if you're running in the LLVM backend, that is probably, LLVM is probably doing something to do a more correct copy, right? Let's go look at that. So yeah, I mean, we just say create mem copy, but that's just some LLVM thing that does something. So that is probably what's doing that for you. But I bet if you do the same test with the x64 backend or compile time execution, you actually will not get the right result for overlapping ranges. What are some cases where you've decided to change something from being executed at compile time to doing it at runtime, or vice versa? More generally, do you have some general rules of thumb that have worked well for you when deciding to do something at compile time versus runtime? Okay. I mean, if you're in the how-to, or in the beta, you know about the how-tos, right? And we have this file called 999 temperance that is pretty short right now, but it talks about, in part, maybe it's there. I hope I'm remembering the right file. But basically it says, don't go crazy using these features at times when they're not necessary or when they're not helpful, right? Because that's been a pattern in all these other programming languages. Like C++ gave people operator overloading, and everybody was like, oh, operator overloading, we're going to make everything an operator, and programs are going to be really confusing, and you're never going to understand what's happening, right? And everybody hated that, right? Same with inheritance and templates and all these things, is like programmers overuse features, often drastically. And so what I would say about compile time is use it for things that you can't really do at runtime, right? So as a result, in the Sokoban game, right, we have a pretty substantial, it's a 1,200 line metaprogram, and it's doing, I mean, a lot of this code, this is code that used to exist for a couple things and we just like splatted it out, and it's a little too copy pasta for my taste right there. But, you know, we generate code. What this code is doing that I'm flipping through is it's searching through the program for either functions that we want to bind to keys through the key map file, right? Or that we want to have be callable from the console. And then it's inserting code to, you know, hook those functions up to the main program, right? It's a way of having your program automatically adjust to the presence of these functions without you having to write glue code that connects them, right? It's removing some of the tedium that would normally exist. And this happens every single time we compile, right? It's not like a pre-process that you run once in a while. It's totally automatic and it's fast enough that we can just do that, right? That's not something you can do at runtime because it's by definition a compile time operation. So we do that. We make different builds down here with different optimization settings. We have various options that we can turn on, like do we want to visualize the heap? You know, do you want to run an official build mode where we send emails when you crash? Like all these things compile different code into the program, right? And I think that's a thing to do at compile time. There are some things that are maybe borderline, like say you've got some table of numbers, right? And you could compute that at compile time to insert into your program, but like it's really not going to change during development. Do you really want to do that? In my opinion, you probably shouldn't. Like, if something is not going to be constantly changing during development, I would output it once and then freeze it, right? But yeah, it's hard to answer that question with more detail without knowing what kind of things you're thinking of there. But in general, so again, you know, our full program, I'm actually not sure how big it is without the modules, but you know, if we go compile again, I don't know why we have to wait 3 seconds for the linker, but we do. So our whole program is, you know, if you just go by file lines, it's 265,000 lines. The meta program is 1,000 lines. So it's less than 0.5% of the size of the program. And that's probably a good idea, right? You don't want it to be big and complicated. You see more people placing import statements at the bottom of a source file instead of at the start. Are there advantages in doing so? No. So the scope file right now, if an import is under a scope file, it doesn't matter. I mean, unless you bind a name to the import. But import directives don't care about scope directives at all. They do a very predefined operation. Why might you put them at the beginning versus at the end or whatever? It depends on what you care about, right? So here's the thing. This is one reason why I don't like, you know, people 10 years ago or whatever got super into like, there should be predefined formatting for every programming language so that you don't argue with people how things look or whatever. But like, part of the main goal of a program is to communicate, right? And that's why I don't like that being unaligned. And so like there's sort of this interplay between tradition and what you're trying to communicate now and how clearly you're trying to communicate it now. The tradition part is just like, because C worked the way it did, we're used to putting stuff at the top. And so this is one of the first files that we made for this program. And like we just started putting the stuff at the top, right? But often if I make a demo file, okay, if I go, so this is for the meta program, right? If I go to the main program, we do some stuff at the top above those that's like configuration variables and stuff that you might want to go tweak by hand. And so this starts to be more about communication, right? It's like, these are the important things that you might care about and want to adjust, and we're putting them all in one place so that you can find them, right? And understand what the things are. And then after that, we go down and we have all our loads and imports, which go quite a while, right? Because it's a substantial program. Why do I still want to put them here? I think it's because and I'm not sure this is the right place to put them anymore. I almost would just put them in a separate file now because there are so many. But for me, these are important because one of the main things you're trying to do as a programmer, as a good programmer, is fighting code bloat, right? And you should be aware of what's in your program, right? That's all. I don't want to sweep under the rug what's in the program, and so it just like, it goes here. And then some globals, and then some data structures, and then some functions that we call commonly. I'm starting to feel like this font might be too small for people, so there we go. And then the actual main function. So it is, though, I would say that it's a point of personal style where you put those. It's up to you. I don't have a policy about what I think is correct, because part of the job of a programming language, I think, and this was somewhat forgotten, but part of the job of a programming language is to enable people to develop styles that are both more effective for them personally, because everybody thinks about things a little differently, but also more effective globally. Like, we're doing some global search about how to program well. That's like what the community of all programmers is doing. And you don't want to say that people shouldn't be able to continue that search, because then you're sort of claiming that we're already done and we're already doing the best thing possible, which is obviously not true, right? So you want to enable smart individuals to continue that search about what's a good way to program. And part of that is style. Part of that is how things look, because when you're trying to program, you're looking at the code, and how things look determine how it goes into your brain. That's just reality. And I don't, I think it was in vogue to ignore that. And I don't think that we should ignore that. But yeah, it's up to you. Wow, I'm giving long answers today. Okay. Wouldn't mind sharing a general roadmap of what's to come. This is a time where we're not being super specific about what's to come. I think because there's just some very concrete problems that we're working on solving. We were doing a lot since the last beta with relative pointers. We actually did internally a very large experiment about relative pointers that we learned some stuff from. We're still not sure how it's going to end up. We might delete relative pointers from the programming language completely. Not in the next beta, but the conclusion of this might be that we just should not have them. I'm not sure. But so, figuring that out is definitely on the roadmap. Right now, DLLs and libs don't really work with the context at all. We have some general plans for making that work well, but we have to try them and see how they go. And then, it's been on my list for a while that I want macros to be more powerful. They have gotten more powerful. There were, Sometimes, you're trying to figure out how to write some code and you're like, oh, I could almost do the thing, but I can't quite do it. And I wish there was a little connection here. And we've added a few of those connections. But yeah, broadly speaking, we don't really use macros that much in the powerful way that I would hope to get to, which is that they're more like the way people would use Lisp macros to like rewrite code and stuff, except strongly typed. And so there's this trade-off that you have, which is when you're strongly typed and you have this complex syntax, unlike the Lisp, everything is a list thing, then, well, your syntax isn't homogeneous, so now macros can't just do the same thing all the time, which has advantages because you don't have all this broken code all the time like you had in Lisp, because people didn't realize it was wrong, right? But the disadvantage is it's more verbose to do that, and at some point it might be so verbose it's not worth doing, maybe, I don't know. And so I just want to get more out into that territory and experiment that and work on that and make those better. Also cross-compiling. You can kind of sort of a little bit cross-compile right now, but it's there's things we could do to make it better. Can I walk through how a macro is compiled and how a function that calls a macro is compiled? It's come up a few times. It's a very different process than ordinary functions. Compilation order, compilation dependencies. Wow. No, I can't. Like, if I were to walk through every step of that, we're talking about an hour-long answer at least, so I don't want to do that. Maybe you could come back with a specific example that we could look at, because that might help ground the question. But in general, a macro is compiled as a syntax tree insertion. Do we have a good, let's just make a new file, right? Right, so I'm gonna put this at the bottom because we don't care, right? I'm going to go macro. Let's just do a really simple one that there's not really much reason for this to be a macro, but all right. So, dude, the razor arrow keys. Okay, so ta-da. What's the difference between this being a macro and not, right? Well, when it's a function, then there's no connection between the calling site and the execution site unless it gets inlined as an optimization, right? But this code lives somewhere else, and you do all this thing that's very similar to every other programming language where you sort of push the parameters in a known way and they get unpacked in a known way and all that, right? Okay, so when we make it a macro like this with the expand keyword, and the reason it says expand was because maybe there's going to be multiple ways of expanding things, which is why we didn't just say macro here. But what happens is this gets substituted down here as a syntax tree, okay? What happens is something kind of like the following. When you say macro sub 3, what gets inserted instead is something like a scope where we bind the arguments of the macro to the things that you passed, right? And then a scope where the body of the macro happens, right? Where this happens. Now, that is why, for example, you can do the following thing, and we have Z is out here, right? Let me just comment this out for a second again to avoid confusion. Okay. There's a nuance to this. You cannot do what I just did, right? It says, hey, undeclared identifier Z. That's because this is a hygienic macro, right? Now, there's one of two things you could do. I think we can backtick this, right? I'm forgetting. Yeah. So you can do this, in which case we say this is not hygienic. And what happens in that case is just when, okay. So this thing that I wrote here is eliminating some details because there's not quite a way to syntactically write the details. But imagine that I had some directive saying the scope of this block is global, right? Meaning, like, if as I look up variables, you go from scope to parent scope to parent scope, and once you get to this one, you look at the global scope. And that's what makes this macro hygienic, right? Is that it can't see the variables here. And that's intentional, right? That's a big difference between macros here and macros in C or whatever. And the reason you do that, again, is for code correctness, right? And to help with strong typing and lack of confusion and all this stuff, right? But so then when you backtick this, it says, just kind of ignore this part. And, you know, the scope of this variable is actually gonna be outside the macro to begin with, right? It overrides the scoping. Now, the other thing you can do, this surprises people sometimes, but it's actually the same. Oh, hold on. We're going to put this back. If I define this macro locally to this function, then it also works. And it's like, why? Oh, wait, it's still backticked. It works even when it's not backticked. And why is that? It's because, well, when I put this directive, the scope of this block is global, that's not really what it is. It's the scope of this block is whatever the enclosing scope of the macro was, which here is internal to this function, right? And so you can hygienically use variables that were declared because any statement at this line would be able to see that variable, right? So that's how those work. The whole thing with backticking may go away at some point. I may replace it with something better. Again, so as I said, one of my goals is to make macros more powerful. And what does that mean is a little bit unclear because it's just like we have to experiment with it some more. But the backticking of variables is kind of limited in that it's very Boolean, right? It's like this thing is either in this scope or this other scope. You don't have you know, sometimes you might wish to explicitly specify multiple other scopes. Sometimes you just naturally get into situations where you have a macro that invokes a macro that invokes another macro. And like right now, you know, there's no way to look like one level up or whatever. And I didn't want to get into a scenario with like typing a bunch of backticks on every variable. So that's just something that we want to think about, right? And there are ways to do that. So like on this expand, we could have a parameter list that sort of says where variables come from. So instead of backticking, for example, I could say just that Z is imported from the enclosing scope or whatever, right? And let's say we had some other foo, right? This could be a list of things, and then you wouldn't have to backtick them down here, and that's nicer and stuff. The problem is, it's not really a problem, but we adopted the backtick notation for other stuff, like when you say backtick return or backtick defer, right? What do we do about the backtick in those cases? Like this doesn't really talk about that. So it's just a thing to think about. It's definitely on the roadmap to revise these though. Why would you not make it an argument instead? I looked at Twitch chat for a second. Because the point of the macro is you don't want to be passing a bunch of arguments or whatever. Here's the thing. Functions are great, right? Functions are really useful. You use them all for all kinds of good stuff. But sometimes they're really inconvenient. And so the job of a macro is to be more dirty than a function in order to help you, right? The job of a macro is to work differently from functions. Otherwise, what's the point, right? And so the real question is just like, what is the best way to like be dirty but not too dirty? Because C is kind of too dirty. There's lots of disadvantages to C macros. So how do you be dirty but not too dirty and maximally helpful? And like, it's a question. I don't know. Okay. The way that for expansion builds an index variable to an inserted code is currently very difficult to replicate in normal macros. That is true. So when you do a for loop, let me rather than ginning up a new example as an illustration, let's look at an existing thing. So like we have bit array, right? This lets you do, actually this one has a little bit, it's got a little bit too much indirection because, oh no, it doesn't, never mind. Okay, so when you have a bit array, let's go back here actually. We're going to delete this whole program. We're going to import bit array. Right? The whole idea of this is it stores a bunch of Booleans, but one bit at a time in these slots, etc. So I'm going to init this. I'm going to say init bit array for 100 bits, right? So many bits. It's like an entire word's worth of bits plus a little bit more. Right? I kind of don't. Why is this here? Anyway. Sometimes a little bit of a C++ mentality carries over into things. Anyway, maybe not. I don't know. So, you can set and clear bits manually and all this stuff, right? But you can also iterate. So let's do a couple things. So we're going to say set bit, bit 5, bit 37, bit 54, all right? Now I can iterate over this thing and using the standard for loop syntax, right? And it'll invoke this, which is a macro, but as we get into the rest of the question, is like, it's a little bit of a special flavor of macro, but you could say for a, right? And then say print, what do I want to call my things? Value and index, right? Now, this is going to be very spammy. Let's make it fewer bits so that we don't like spam. There's no point to do a 20-bit bit array, but whatever. Okay. So let's see how many mistakes I made there. Oh, great. So there we go. So we're iterating with just the standard for loop over the bit array, and we get true values here. And it didn't take this is the entire thing that implemented that for loop. Now, this is way less code than the C++ way, and I had a speech or a demo that's on YouTube where we talk about why we do it this way. Doing it the C++ way is a lot more code. To create this weird iterator abstraction that actually most people don't care about, right? So now, there's some special things. So here, like I said, this is very spammy because we're visiting everything. But you can give an alternate iterator, right? So we have, for example, only set, which is a bake of only set or unset, which is this thing. This is like a slightly specialized version of an iterator that skips over the ones that you don't want. So if I want to say, give me only the 1 bits, which is a common thing to want, right? Then I can just do that. I could say for only set, and now we only iterate over the 1 bits, and there we go, right? Or I could say only unset, and we get the 0 bits. So that's very convenient and expressive, but there's a few things that are like hard-coded for loops in these macros, right? There's like this ability to rewrite, remove, and break, for example, is the main thing. But then also this macro exports values. You can export declarations into the enclosing scope from any macro, but this one, it specially knows that if there's something called it or it index, that it should rename those to like whatever these names were, right? And so that's sort of what the question is talking about, is there's these things you can do from the for loop where the for loop does the special part of it. So if I wanted to call this iterator without the for loop, it's maybe weird and more difficult. You can do it, you just have to like put some stuff around it. Does for expansion become less special as things like it index become available for regular macros? Yeah, I mean, this is tied together with what we were talking about on the previous question. In the same way that we have this expand could take parameters of whatever we wanted to be backticked as an input. Maybe there's 2 parameter lists, right? And we tell you what is going to get exported. This is a little bit tricky because right now we actually allow you to declare, like it index is declared like 5 scopes down here, and it still gets exported. But I don't know if you start saying stuff like this, but you could imagine a macro saying stuff like this, where it's like, these are the variables that are going to be exported from this macro into the enclosing scope. But you kind of already have that ability, right, with a backtick. So that doesn't change. The thing that's special about the for loop version is just that this can get renamed. Do we want to introduce a general rename syntax when invoking a macro? I don't know. It sounds sketchy, but maybe we just haven't thought about it enough. Hard to say. I'm not sure. I guess that was mostly a summary for people who didn't understand the question. So sorry, but I'm not sure that I have more to say there, except that, yes, like, okay, generally speaking, it would be great to both simplify and generalize these for loop specific things so that they're not special anymore and hopefully could be used in broader ways, right? But I don't have a very solid idea how to do that yet. I haven't been thinking about it very hard because I've been thinking about all these other things. So it's possible if I go just like, work on this, that maybe something would become apparent. But, I'm also open to suggestions, so you can email in and say, hey, I think it should work this way or whatever. Like in general, people's expectations should be that macros are going to get a pretty big overhaul at some point. It's just like, what does that look like? I don't know. We got to figure these things out. Someone says, I was surprised to find that unlike in C, I could get an add. I'm just going to put the example down here. He has, I'm going to call it B because we have an A. And then P is star star B. Yeah, you can do this right now. What happens? So normally when you do this, right? This is a totally sane thing to do. It's like, here's a value. Let's get the address of that value on the stack. This normally would be like a very weird thing because like if you were to say address of P is a thing on the stack, and that's a very coherent idea. But the address of B doesn't necessarily have storage, right? So like, how do you take the address of that? And what's going on here is that right now we automatically make storage for the thing when you do this. And the reason is because there are some mechanisms, like for example in any, right? You can do this. Let me just do this. Well, it just prints 3. What I put in a way to make it not. I don't remember. Anyway, this is a struct containing I guess we don't define it. Okay. We don't call it any here, but this is what it is. It's a struct with 2 things. It tells you the type and a pointer to the value. And the reason it's a pointer to the value is the value could be arbitrarily big or small, and we want an any to be the same size so that things can treat it uniformly without being polymorphic. Okay, so when you say this, we're taking the address of this thing, which seems fine here because again it's B, right? But what if I said address of B? That kind of needs to work. And you might say, well, this is stupid. Okay, let me make this a little more clear. When I say any equals B here, right? This is shorthand for any dot, let's go back and look at this, any dot type and value pointer, right? So it's shorthand for saying any dot type equals type of B and any dot value pointer equals address of B, right? That's really what the compiler is doing when you say that. And so what if I say instead of any equals B, what if I say any equals address of B? Then we put address of B and address of B. And so we need to be able to do this assignment. And you might say that's a stupid thing to do, but like that's how print functions work. And a lot of our a lot of var-args-ish things where you don't want to like dive off the cliff into weird polymorphism work this way. It's a very chill way to write code. And so if I say, the point of all this is, if I say this, which is a totally normal, sane thing to do, I want to know the address of B. That works. The reason it works is because we made an any, the value pointer of which is the address of B, and passed it in. And I don't want to dwell on this anymore. Anytime you talk about address of whatever, it gets confusing. But like, if you want to go step through it or whatever, you can get what I'm saying here. And now, the question is though, is this a little bit of an error-prone thing to do? And the answer is yes, sometimes. So like if you pass a big argument into a function that's read-only because it's like a big struct or whatever, and then you take the address of the struct, I think right now we make a copy of it. Actually, that's a little bit of a different issue, actually. That's more about guaranteeing lack of aliasing. But it's just to say that there's a couple of very related mechanisms in which we automatically make storage for things to take the address. And it's maybe a little bit too overeager right now. It's maybe a little bit too willing to let you do something you didn't mean to do, right? Because if you did this in C, it probably says this doesn't make sense. And If you didn't want it to make sense, then that's a good thing. So, one opportunity or one option that we have is to only allow this kind of address of address thing if it happens in implicit code generated from an any or whatever. And it's just, that's a little bit of a tweaky thing to say. Is it the right answer? I don't know. How come context.allocator works as a default argument in functions, even though it's technically not constant? Because I made it work. There is literally code in the compiler that says if it's context.allocator, it's okay. Is that a good idea? Not really. I mean, it's fine. It's one of these things that programmers think of as messy, but sometimes that's actually a good solution. Now, I think the broader question, let's go to one of these things that actually does this, right? Oh, you know what? I think I took it out. I think I stopped using it. Oh, no, there's one. So normally, when you give a default value to an argument to a function like this, it has to be constant. Why does it have to be constant? Well, that's actually kind of an arbitrary decision that I made a long time ago. There's not really, in principle, some reason why you can't just put a bunch of code here and then just whoever's calling the function just invokes that code, right? However, this is another one of these things where maybe that's just really wacky and results in programmers being unsure about what's going on. Like, dude, I'm calling this really simple function. Why did we launch the nukes, right? And that's why there's this restriction here. But, in this one case of allocators, it's like, but you kind of want to be able to do this. That's all. It's just really, it's a special case exception. Are closures capture still on the roadmap? They're just not very high priority because I don't find that we really need them. But I was actually a few weeks ago going to do the next step toward those and then just ended up doing something else. Is it legal to modify a string? No. I mean, a compile time string literal, no. No, you can't do that. Yeah, don't do that. Implementation detail-wise, in principle, the compiler would make strings read. So, okay, I'll show you guys what the problem is. This code's on another laptop, right? So he's saying, right, I'll only do part of it. He's saying this. Well, we'll do the whole thing, whatever. My string 2 is the same thing, and then my string 1 sub 0 is a B. Yeah, you can't do this. If you do this at runtime, you will probably crash because these are probably in read-only memory. If you do this at compile time, you don't crash. And the reason is just because in principle, we could store this stuff in read-only memory. So to catch this problem, the problem is just that in reality, it would slow down the compiler a great deal because we would have to keep toggling security on those pages as strings got added. And it's just, I mean, I haven't actually timed it, but I imagine it's just way too slow to do. And it's not something we want to be in the business of doing. But this is not a legal thing to do. Seems like there are more and more people recently who end up in situations that require poke name, mostly for data structures like hash table to be able to see custom double equal operators. Yes. Okay. So this is one of these decisions that we made where there's what is hopefully only a short-term downside where we come up with a new a new way of handling things that results in a better upside, right, later. So again, traditionally, well, not traditionally, but like what happens a lot of the time when people make programming languages is, they start making features a certain way, and then they say, oh, if I don't copy the way C++ does this or the way C# does this, then I won't be able to get this result that they have, right? And the problem is that leads toward sameness. Sameness of programming languages. And so sometimes you have to just decide to do things very differently and then just see what the issues are and then have faith that you'll be able to cope with the issues. And so the issue in question here is, in a language like C++ or C#, I'm going to start snacking, by the way, because I'm getting kind of hungry. Yum, yum, yum. We might mute the mic for a minute as I eat delicious high quality Rice Krispie snacks. In a language like C++ or C#, the object, quote unquote, which is essentially a struct with methods and maybe some other stuff, is considered to be authoritative over what happens to it, right? So, for example, if you have, let's go directly to the question here, which is that if you have some hash table in C++ and you have some operator double equals that the hash table wants to use, because the hash table is looking in all the slots of the table and saying, is this the thing that we're supposed to return back to the user? Ultimately, we have to do a comparison by value on the thing, or some way to know whether it really is. Because the whole point of a hash table is that things get aliased to each other via the hash code, right? So you have to disambiguate. So you need an operator equals. And in C or C++, or not in C, sorry, not in C, in C++ or C# or something, when you say double equals on something that's like a struct or whatever, the compiler goes and asks the struct that's the argument to equals, what is your definition of equals, right? Okay, so in this language, there's sort of two, at least, major decisions that bear on this. One is that, we don't really have objects. It's not really object-oriented. We didn't want to buy into any of that stuff. And the thing about all the object-oriented stuff is once you start buying into it, like the decisions that are made in languages like C++, like some of them are just stupid and bad, and that's more true lately than it used to be. But a lot of them is just, yeah, there's a reason this decision was made this way. It was because of this previous decision. And that one was made that way because of this previous decision, right? And if once you start walking down that trail of decisions, it's not very obvious that there are other places that you could end up that make sense. This is what happened. So a long time ago, I did constructors in this language and was trying to keep them simple and not buy into all the C++ consequences of having constructors. And like, there's a lot of it that you could get rid of, but some of it that I was still very unhappy with in the end. Because you end up with, this whole thing about as soon as you have the idea of constructors and things are supposed to initialize themselves or not, it's like you have all these problems where you can't really have an array with uninitialized elements because somebody's going to assign to an element and that's going to destruct the thing and it was uninitialized, so your program crashes, right? So it seems unrelated, like you feel like you should be able to introduce the idea of a constructor without slowing down everybody's program because you're just like, look, if you don't want to use it, don't use it. But like actually for correctness, everybody has to make their program slower, right? That kind of thing just happens. So going back to this actual issue, I didn't, so that's one of the things is, I'm trying to figure out how to hook this back up to what I was going to say. So firstly, we're just not object oriented, right? There's this idea that objects own functions is not what we do for multiple reasons. One reason is performance, because the way you get performance on modern computers is by having functions acting on large groups of objects, large batches of objects. If every object in a batch might have a different opinion about what you should do, your code simply cannot be fast, right? And by faster or slower, I don't mean 10 or 20%. I mean 1,000 times faster, right? So that's a big deal. And that's one reason why you don't want objects to own functions. But another reason is just that there's this kind of stagnation that has happened in programming where everyone is too eager to like black box things off and not understand code beyond an abstraction barrier. And that seems to lead actually to very large programs, which I guess it's a little bit obvious in retrospect that happens, but I don't think initially that was expected by people encouraging you to do this, right? And so what we're attempting is just a philosophical reorientation where it's like, look, the struct is just data, and part of what that means is that if you, as the person who's using some code that somebody else wrote, if you have a different opinion about how you want it to print or how you want to compare it for equality or whatever, you should be able to have your opinion of that be at equal standing with the person who wrote the original code, right? And so the way that we do that is just by having functions take objects or structs and whatever as arguments in this straightforward way, and not doing that reverse lookup mapping thing. Now, there's one other thing that also is a good idea independently that makes this even a little bit more annoying when it comes to something like a hash table, which is in something like C, you have a global, and C++ just inherited this, right? You have a global namespace for your whole program. So in C or C++, if you define an operator equals for something in a global scope, and then you include other files, they can see that declaration, right? As long as you declare it first. And that's an annoying pain in the butt in those languages, but you can at least do it. It's like you get your includes in the right order and whatever, and they can see your operator. That actually cannot really happen here unless you do some other things because, well, okay, the downside of this thing that happens in C or C++ is that any code that you include can arbitrarily break if you accidentally defined some name that they're using in a different way, right? Whether it's a function overload or like a macro name that they're trying to use, or they think it's a variable, but you think it's a macro. Like experienced C programmers have seen this all over the place, right? And so we made the decision early on that we want to gain ironclad assurance that you cannot break third-party code just by importing it, right? And the way that works here is that it does not have the same global namespace as your main program, right? Therefore, nothing you define outside that module can cause that module to compile incorrectly. However, this also means it can't see your operator equals, right? And so I introduced this thing called poke name a long time ago, which is what this question was about, which is about just take this declaration and shove it into that namespace. I don't necessarily think that is the best way to do it. For hash tables specifically, though, I think for the hash table that we provide, I thought we added this as a parameter. Yeah. So for our hash table, you can just pass the, because when you instantiate a table, you're instantiating it for a given type, you just pass the compare function in, This is a compile time parameter, so this can still be inlined and whatever, right? So for hash table specifically, didn't you bring up hash table? Yeah, like, so first thing I did was poke name. Then I said, well, this is probably cleaner, right? And so I've been doing it this way, and this seems fine, unless you need like a bunch of functions, and then you're passing a whole lot of parameters, and that's annoying, right? So now, what I'm going to say is, so part of the answer to this question, you know, I think a lot of these answers are mostly going to consist of context for the people, right? But part of the answer is we're still sort of experimenting and considering ways to do things. Like, for example, maybe we should just make a global namespace that's common to the whole program, but by default, it's completely empty unless you put things in there. And then you would have a scoping operator like, you know, scope global or something that would put things in there. That's one thing we could do. It would be a pretty straightforward extension of what we're doing right now. That would have the downside that then maybe you could break modules. Still not as easily as C, but like, for example, you know, overload resolution works on this scoring system about what's the closest overload. You might add something to the global namespace that's a closer match than something that the module is already matching a little bit more loosely. And now it calls that and things break and you don't know why, right? So, but if that only happens for very specific things that you put there, maybe it's fine, right? Now, another thing that we did though, is if you look at, for example, getrect, I think simp does this as well. We pass an interface type in the module parameters. So this might be a pattern that you could use that's very clean and will not cause any of that kind of problem that I mentioned about weird overloads or name lookups or whatever. So here, this is a module parameter, or a program parameter actually, where you pass this thing called a type indicator. All right, what's a type indicator? It's a struct with a bunch of static compile time bindings for things, right? So this defaults to void, which is what you get if you don't pass it. And at compile time, we say, oh, if it's void, then we're going to use simp as our rendering backend, right? We're going to use the window creation module. These are going to be our types for things. There could also be functions in here. I'll show you the, there's a different one for functions. We'll find that in a minute. But you know, this is for defining various types in a way that, like in C, you normally would do it with this include file kind of mess, and here we don't, right? So if you pass a type indicator that has these member names, then now I can tell this like, hey, I want my window type to be this type, and I want my font type to be this type. And so it's a way of getting a lot of abstraction out of your system while still having it all happen at compile time. We're not doing runtime like dispatches to figure any of this stuff out. Okay, so now, the draw procs is what I was actually thinking of though. So draw procs again is a struct with a bunch of functions, and oh, I guess I made this one runtime because it's not that big of a performance impact just to like look these up at runtime, I think. We should measure that. But you could make it compile time as well. So where does this get set? Yeah, when you call the init function for these, you know, if we're using simp, we set up all the draw procs. Otherwise, we assert that the ones you passed us are not null and use them. Okay, so some variant of that kind of a structure could work for a data structure that wants like a lot of methods for things, is you just pass them all in a struct, or you default to something. Or maybe we could do the global namespace thing. Maybe we should just make poke name better. One of the things about poke name is, one of the reasons I haven't documented it yet is because you kind of don't have a lot of control over where things go. Like you ideally should be able to pick file or module scope or exports, you know, like you should be able to declare where things go. And you kind of don't have that much control right now. Okay, that was a very long answer. I'm going to turn off my microphone for 1 minute and eat some Rice Krispie snack. I hope everybody is doing well. You know, in general, one of the things I am not that good at is having a relaxed speaking voice. And I think in the current room that I'm recording in, because it's so echoey, that, I don't know, I'm wearing out my voice more, I think, is the point. Anyway, the next question happened to be about scope directives to access stuff. Like, can you access stuff that's in, you know, in a file scope, even though normally you wouldn't be able to? And yeah, that's on the roadmap. And again, it's sort of just a matter of, because it's very easy to just hack in some weird directive that says, like, look in the file scope, right? But, you know, programming language design is about figuring out a nice thing that solves many problems at once. And so we were just talking about poke name. We were talking about macros and how they expand and where the names go and whatever. And so ideally, we could figure out some refactoring of these features that makes a lot of things just nicer and cleaner. And then that's how you know that it's the right direction to go, right? Can I speak a bit for the compiler noobs about linkers? I rant about linkers all the time, so I'm not going to do it right now. Linkers mostly shouldn't exist. Like, people don't understand what linkers are for. Almost all work that a linker does now is waste. But as you've seen, sometimes it takes a very, very long time for your linker to run. I'm actually very bummed about this. On this new laptop, like, mysteriously it takes, you know, 5 times as long as it did on the old one. Why? I don't know. Something's installed. Has a programming language changed the way you make your game's tech? For example, making the editor output code. Let me put this over here. I feel like if I read toward the microphone, it'll work better. Making the editor output code that gets compiled into the game instead of it just outputting normal data that the game reads at runtime. The answer to that is, I tend to be pretty conservative about these things, actually. But also, I'm not really sure what the editor would output. that would go into the game. I mean, maybe, so if our editor had, for example, like a bunch of Unreal, like Blueprint style game logic, I could see compiling that into some functions and stuff, but we don't have that. So I don't know. I never have seen opportunities to do that. In general, I try to resist being too wacky about that stuff, but that also means maybe I missed something cool by being conservative there. More details based on your answer to the previous when to use metaprogramming question. Let me get this off the screen. Some games end up making small scripting languages to allow designers to create some functionality, like give this loot under these conditions. Are there benefits, drawbacks for this to be in the actual programming language versus just data that the game parses in runtime? Yeah, I mean, I've talked about this on stream a bunch. Maybe somebody knows an old YouTube link, but like scripting languages was a fad that games went through in the late 90s and early 2000s, and everybody thought it was going to be the future. And basically everybody regretted it. The thing is, not everyone got the memo, so you still have engines like Godot that ship with a scripting language they expect you to do things in. But that's just due to lack of professional experience is why. Like the problem that happens is, you have this programming language that's like not that good of a programming language because it's a scripting language, and you're like, that's fine because only small things are going to get written in it. But what you find is that by the end of the project, there's a lot more stuff written in the scripting language than you expected. It runs in a lot more iterations. You spent a lot more time writing glue because the scripting language can't magically make things work, right? Like the engine has to give it the way to get information and to make changes, right? And so all that is things that require ongoing maintenance of serious programmers, as designers using the scripting language run into things they can't do. And then in the end, it slows your game down tremendously anyway, just by much greater factors than you ever expected. And so nobody really does this anymore, or high budget games don't really do this. Also, like the other problem that you have is, surprise, surprise, people who are not professional programmers will tend to make bugs when they try to do complicated things. So now you have all these weird bugs in gameplay script that's harder to debug than your systems programming language, right? So it's bad. You don't want to do it. At least you don't want to do it in the late 90s, early 2000s way. Could you have some scripting language that's maybe more strongly typed or maybe more visual like blueprints, but that also compiles down into something fast so you don't slow your game down? Yeah. I do think there is some kind of workable like middle ground there that's useful, but it doesn't look like a scripting language. That's the thing. Like we tried that. It doesn't work. Oh, there was an edit there. Ugh. See, I don't have my mouse plugged in. All right. Yeah, that's one sneaky way to get your reply in, is to edit your comment that I'm replying to verbally, and then I see the thing. Update about the drawbacks in scripting languages, so I'm considering using the real language in the editor and compile that in. Yeah, I mean, the problem is, designers, they're not professional programmers, right? And so giving them the same programming language that you would give for career programmers, you're asking a lot, and you're probably going to get a lot of problems. I don't know. Like, I don't really have time to work on this kind of thing. If I did, I would try to do something visual. But again, like most I got the hiccups from this soda. Most visual languages have sort of converged on the same idea of like, well, there's sort of two ideas. There's one that looks like a flow chart, and then there's one that just looks like a circuit with boxes and lines between them. And those are both sort of the same thing too. It's just they diverge a little bit. But like nobody else has another idea than those. And I feel like there must be a lot of other ideas than those, right? I just don't know what they are. Related to the previous question about alternative to poke name, oops, we can already pass a codev to a module parameter, but can it be already a sub? I don't understand. Okay. Also, what do you think about exploring the idea? So he said I actually ended up answering that question, so it's fine. I didn't understand the question, but it's fine. It's been answered. What do you think about exploring the idea of passing a bunch of code that contains procedures or a whole module to another module to expose declarations, checks implementations, and or generating stuff? It is hard to answer that question without a use case. My question would be, why do you want to do this? Why do you want to pass a giant amount of code full of declarations to a module? Is it just because it's cool? Or does it help you solve a real problem? And without use cases, I kind of can't tell. And it's a danger, it's a constant danger when people have new programming languages. They're doing stuff just because it's cool. And like, it's not actually that cool to do stuff just because it's cool, because we've seen that over and over. It doesn't end well. Will there be a function added to simply read from console? I mean, that's just like, what? I mean, I guess we should put that in somewhere, but like, dude, do you know how many centuries it's been since I wanted to read from a console? All right. But yeah, like the thing is, that's just a user level function that anyone can write. I'm sure someone has written it. You could get a copy from them. If we see an implementation that we like enough, we'll probably put it in somewhere in one of the modules. Yeah, it should be in there somewhere. Okay, so there's a question. Casey's doing his class Computer Enhance, and he's doing a bunch of SIMD. Are there future plans for language to have things like SIMD built in beyond just the ASM directives? Things like having basic data types like S64 by 8 and use SSE for them? Not really. So, okay. The ASM directives that are in there right now is sort of our first step at supporting things like SIMD. Here's the thing. They are basically, so when you look at Casey's Computer Enhanced class, he is using SIMD intrinsics to do these operations. Like add 8 floats at a time and whatever, right? There's just ASM instructions for the same thing. Early on, we had this question. Do we want to go this route of declaring a bunch of intrinsics, or do we just put an assembler in? And we decided to put an assembler in because it gives people more explicit control, and that has a number of advantages. So for example, a couple days ago, Casey tweeted this complaint that, in debug on Clang, one simple intrinsic, I forget what it was, but it was some simple intrinsic like add 8 floats or whatever, was getting blown out to like 50 lines of assembly in debug build. And the advantage of just saying what you want as opposed to an intrinsic is that you get exactly what you said, right? And so that's the route we decided to go. Now, when it comes to so when you say basic data types like S64 by 8 or whatever, those are things that people can just declare. Like that's just an array of stuff, right? Is there some advantage to those being in the compiler? I don't think so right now necessarily. There would be if you were in a paradigm where we're doing lots of intrinsics and we have lots of these things on the stack, but they're really supposed to be in registers the whole time, and we're relying on the compiler to make that optimization for us. But the problem with that is that the compiler may not do those optimizations, and then your thing's in memory, and then you're sad, right? Now that said, if we see a good way to do it, we can always change what we're doing. But right now, I don't see a ton of point there. Now, the other thing you might imagine is like, oh, if I have these built-in data types and then you say plus between them, then the compiler can automatically make that a parallel plus and whatever. And it's like, yeah, you could do that, but that doesn't actually get you very far in terms of the code that you actually want to write. Like, writing the intrinsic for add is not that much more than writing a plus sign. And on the other hand, there's 157 other names of operations that you want to write that there is no operator syntax for, right? Like once you actually start solving problems with SIMD, you're doing all kinds of like, you know, oh, it was a broadcast that he was doing? It was a but you're doing all sorts of like, you know, broadcast and swizzle and whatevers. And it just, the allure of just saying plus to add 8 or 16 things or whatever is just not that great once you're looking at the stream of all the things you want to do. Okay, but so we obviously want to improve on the assembler stuff that we have. We obviously want to make the integration with the rest of the compiler better. And yeah, so this is definitely an area for future expanded work. It's again, though, it's just a matter of figuring out quite what the right things are there. Dude, not having the mouse plugged in is brutal. I only have one mouse, and so I transferred it to my new laptop. Okay. Have you tested, validated, compared the use of 64-bit integer as the default integer size compared to C++ 32-bit int in the Sokoban game, particularly memory performance drawbacks? We haven't really done any A/B testing of that kind of a thing. I will say I doubt that it matters. Oh, I left this up. Didn't mean to do that. Sorry about the ugly video. I don't know. Looking at random code is maybe not that much better. I could get all bigger for a little bit. So okay. So default integer size comes in a couple different places. One is if you just say int, right? Actually, let's make me smaller, then we'll do some code again. So when you say, you know, a int, that's 64 bits. But also when you say x is, you know, an array of strings whatever, right? So, okay, so this is where we get into the nuances of what things are, which the casuals may not know. Oh, I have to say size of type of. You would think, see, I was going back into my head about whether I had to do that. Okay. Let's declare one of these and make an equal. So this is a different type from an array of 3 strings. The array of 3 strings, I'm trying to make it as simple as possible. It's fine either way. Actually, no, you know what? Screw it. It's a string. It's a string, right? Okay. So this is going to be 16. And the reason is you have a pointer to the data of the string, and then you have a length number, right? And that length number is 64 bits because we just don't want to screw around and have problems with potential overflow, right? Now there's other cases, right? So if you have an array of float, I don't know, whatever, right? And we print the size of A there, you're going to see a very similar result. And the reason is because this is the same thing. There's like a pointer to the data, and there's a count number. It's how many floats. And that's 64-bit, right? Now, are there times when this is going to like matter performance-wise? I don't really know. The two most obvious times you would think is like in terms of just overall size of your data structures, where hopefully, it's not always true actually, but hopefully if you have arrays of things, then the number of things in the array is going to be at least medium to large, and so you don't worry that much about the overhead of the array. But even if you did, the thing about this is, like once you've got a 64-bit pointer here, which you pretty much need for many use cases, you kind of can't have a 32-bit count or something. You're probably going to have wasted space unless you're like manually packing a bunch of stuff together or whatever, right? So there's that question. But then, so the other time you might think is just, oh, in terms of general CPU operations, you know, maybe the 64-bit is bigger, right? But in terms of, you know, the way that you're going to encounter this number is in like looping, or why am I looking at, I keep looking at the microphone now that I decided to talk into the microphone. That's not working either. Looping or, you know, just comparisons in general. And like, those are not going to be any faster on a modern CPU, whether the register is 32-bit or 64-bit. In fact, they're mostly completely covered. Like those are very easy operations to overlap with other operations. And so it's just not going to matter. And that said, we haven't done like an A/B kind of a test. It would be very difficult to do such a test, I imagine. But we're kind of just too busy getting the game done, right? We definitely, so when we're working on this game, there's definitely stuff we wish was faster than it is. 0% of the time has that ever had to do with integer size though, right? It's just, games are complicated. They do a lot of stuff. That stuff is hard sometimes. That's what makes things slow, right? It's not really ever the default integer size. That said, if it ever turned out that the default integer size was a problem, I would definitely think about what to do there. But I'm, for the most part, well, for the complete part, I'm happy with the decision. I've never had any reason to think that that was the wrong decision. It's just, I know that there's going to be the occasional like grognard C programmer who's like, I want an array with 16-bit integers, and it's, well, So in part, that was also, though, what the relative pointer stuff was for, which is if you have an array, if you know you don't need the full 64-bit range of the pointer for that array, if you could fit that pointer in 32 bits or 16 bits, then now it makes sense to have a smaller length as well, because now you could pack both of those into a nice compact size that like fits somewhere. But like I kind of said at the beginning, relative pointers may not be working out. We have to see. But they're producing a lot more complexity than they generate in benefit. How's the experiment with non-constant struct literals going? I consider them successful, so I don't think that we will remove them. If anything, if people want, so this is one of these things that I did speculatively in the beginning, which is like, oh, it's nice to have an assurance that the struct literal is constant and that's fast. That is nice, but in reality, also a lot of the time you just want to be able to generate a struct from non-constant things. So we made that change a while back. I think it's a good change. I think it'll stay. If we want to get back that assurance that a thing is constant, we could always add a directive or something, right? The assert if this thing isn't constant directive. Yeah. So there is one problem with it right now is I've got like 17 zillion bug reports because of the same bug, which is that if you have an array containing non-constant struct literals right now, the array thinks it's constant because we haven't done non-constant array literals. So we either have to do non-constant array literals or just detect that error. And I don't know why I guess I just forgot to check for that. And so it's technically not legal to do that right now because there's no non-constant array literals, but the compiler doesn't nicely tell you that. You're using a approximately 1 month old version of the compiler, but there seems to be no explicit licensing information. I thought we had a license file somewhere. If we don't, we should look at it for sure. Is there a how-to or reference that has info on printing a macro expand a la program print? There isn't totally, like program print itself is like not totally done. I use it sometimes. Sometimes when I use it, it's missing some things and I add them. But that's kind of why it's not really documented, is because it's not totally done yet. But if you wanted to print out a macro, that would be the way to do it. Hopefully there's an example somewhere. I'm trying to remember. I just did something recently where I used program print to print non-trivial bodies of code. It was a few weeks ago, but I don't remember what it was. I'm wondering if it made it into the examples. I don't know. Anyway, we can definitely put together an example if y'all think it's going to be helpful. Wow, we're getting toward the end of the questions. Hooray. Haven't thought about this very well, so it could be a bad idea. Could you do something where you combine different scopes by labeling them? So if a scope contains all variables within that scope will be available from every other scope. Okay, here's the problem with this. The problem with this is, for the naive version of this program, or for this feature, you never can compile a program. And the reason is, this is not a problem you would have in C necessarily. But the reason is, because we allow you to come along later and add new source code to your program, right? So what happens if you've got some scope somewhere with some stuff, and then at the very, very end of compilation, we add something that changes that stuff. Now you've got an inconsistency. This is actually, this is a sort of a problem that we already have in some way, that we solve in a way that I don't totally love. So, you know, we have function overloads. If you, you know, overloads can be added onto, like if you import a bunch of modules that all define functions with the same name, those will get put together into like an overload group. And what happens if you call some function in some overload and then some other module adds to that overload? Again, you could end up in a case where it's a better match for the thing you already looked up, right? So in principle there, you kind of can't ever compile the program because somebody might add new things. Now what we do currently is we say as soon as somebody uses that overload, you're not allowed to add anything to it. And in practice, that's not too bad for that specific case. I don't love it. What I would like to change to is maybe a system where we check afterward whether that would have changed anything. The thing I'm worried about is that just might be really slow. I don't want to be like some kind of Apple Swift situation here. So anyway, to get back to the question, this is another instance of that, because if you could just say add stuff to this scope that's completely across the program, and there doesn't have to be any markup on that scope, then the program never knows when it could compile a scope, right? So first of all, you would need to have a designation on the scope that it's editable, which I guess you would need anyway to refer to it in some way. But I mean, there's other reasons to have names for scopes besides this, and so that's a whole question. But yeah, you would also sort of need a way to say when you're done so that we can compile. And it just hasn't seemed worth it. It's one of those things that seems really messy and not that worth it. But this does play back into all these earlier questions. Like a lot of these questions that we have right now are around namespacing, like all the macro stuff and the for loop stuff and the whatever, the poke name things. It's like, okay, it's very clear that there's some shift that we want to do in the way we handle scoping. And it's not 100% clear exactly what is a good idea there. So we might just do some experimentation. I don't know. What modules are exactly? Am I able to use static polymorphism, static dispatch with several modules? I don't understand the question yet. Let's see if he clears it up. Let's imagine I have some interface, just a struct with some fields, or using interface in functions for the allocator in one module. For the allocator in one, okay, I don't understand that part. And one of the implementations of this interface with overloaded functions is in another module. Are you able to resolve all the overloaded functions in compile time? Yeah, I mean, that just sounds like an example of what I was just talking about, where overloads can be modified. Like, as long as you perform the import statement initially, you shouldn't have the problem that I just mentioned about trying to use the function before the overload gets added, right? That kind of thing happens like if you generate some code that gets added to the build after all the initial stuff, and it imports something that imports a declaration of the thing that adds to the overload, then you're like, we already used this, you can't do that. But it sounds like you should be able to do what you want. But again, it kind of, absent a use case, I'm just wondering, do you want to do this because it's cool? You know, there's an example of reading from console and modules process examples, run programs in parallel. Okay. So maybe we should just make that easier to find and or more official. Unreal moved a lot of its systems to work with 64-bit floats as default for UE5. Are there drawbacks to making the default float 64-bit? Are the drawbacks different? Yeah, I mean, this is definitely something I thought about because it's very obvious. If you're going to make your int 64 bits by default, why not make your float 64 bits by default? And I just decided against that. That may or may not be the right decision. It's kind of a trivial decision in that well, except it's not. It's like, okay, one aspect of this decision is just when you say float, right? If I say X is a float, Y is a float 32, Z is a float 64, right? X and Y are actually the same type. Float is just an alias for float 32. Now, another aspect of this, so this one, you just type something different in your program, no big deal. But the other aspect of it that's much like more baked in is just like, what do we provide as vectors and matrices, and you know, what's the convention around what you pass around? And those are all float 32s. And you, of course, can have your own module that does float 64 versions of vectors and matrices, but that's no longer the code that we give out with the compiler. So just other people may not interface with, or won't necessarily interface very well with that, right? So there are de facto consequences of this decision that are significant. Why? Well, the way that you would use floats typically is as a large array of data often. And it's just a lot faster to operate on float 32s. And when float 32s, like, it's possible to have a little bit of precision loss and you're kind of okay. Like, nobody loves that, but you're kind of okay until it gets catastrophic. Whereas, like, the instant you increment a 32-bit int and overflow, your entire program breaks, right? So it just feels different to me in terms of what is the failure case, and in terms of what is the what's the cost? How expensive is it to go 64-bit there? I think it's a lot more expensive. That said, I do feel like this is a decision that is relevant to this point in space-time. If you go far into the future, I would expect 64 bits to probably be the default. The thing to keep in mind, though, is like, dude, on the other end, AI accelerators and stuff are trying to do 16-bit floats or even 8-bit floats sometimes because they need that much more speed. So like 32-bit being the default isn't that crazy when a lot of people want 8-bit, So I don't know. It's just one of those things. It's one of those things where, I try to make the best decision possible at all times. And sometimes that may not seem consistent with other decisions, but usually there's a reason why it was made one way in one case and another way in another case. Did I also exclude LLD from the antivirus? No, but I theoretically excluded the folder that it's in, but I don't know if that affects it or not. Was the question about bypassing scope file answered? I mean, that's just part of what we were talking about before that, is just like, yeah, poke name and macros and scope file and all that. Yeah, I think I answered that. It wasn't a long answer because it was just related to what we were already talking about. Hey, we have gotten to the end of the official questions in the beta question channel. If we'll give it another 30 seconds for anyone to drop more questions in. Otherwise, I could go read Twitch chat for a second. how would you define entity structs to handle a lot of types? I do not know what handle a lot of types means. If you could be more specific about that. I was thinking of something like this. Scope name. Yeah. You know, I should install Discord on this so I could just like show people what I'm looking at, but I didn't do that today. So the example he's giving is reading from a scope at a distance, which is different from writing to a scope at a distance, right? Reading from a scope at a distance would be pretty safe, sort of. But this particular example doesn't make sense though, because he's got a variable on a stack and then printing it from another function with a different stack. Like that variable doesn't exist. So you can't do that. That variable doesn't exist. Types, player, pickups, walls, foliage. So you mean, yeah, well, I mean, what we do, what I've done in several games in a row, and that works fine, is we just sort of have this 2-layer, it's like inheritance, but it's only one level, right? So, so we have a base, which is called entity, which is honestly way too big. We would like to chop it down, but it has all these things in it, right? Some of these members could probably go away. Like I think we're deleting the mounting system and whatever. This light map textures, I don't know why that's there. I feel like that's the wrong place to put that. Anyway, so there's a ton of stuff there that's common to all entities. And then for each individual entity type, we just say, well, it's an entity, and then here's some more stuff. And that's really, you know, that's all we do. It works fine. We ship games that have millions of players. You don't need to write a PhD to do it. Is it a good idea going forward to name procedures very generically? We talked about this last time, so I don't want to beat the dead horse again. The answer is maybe. Answer is maybe. Like, definitely, again, so, you know, I was speaking earlier in this session about, you know, sometimes you make decisions and you know there are negative trade-offs to the decision, but then you say, well, later we'll try to solve that and come up with something good. And so we won't let that prevent us from exploring this road of how to do things. With this question about should I call my function add or array add or what, right? The problem is if 1 million people call something add and then you mess up sometime, you get an overload, you get an error message that says here's 375 overloads of add and none of them are what you want. And the compiler does that right now if you do that. And so that is a negative trade-off. Like, I don't think anybody wants that. The question is, what can we do that's better? So you could at least pick some and say, well, we think you're probably trying to call this one and these other ones are irrelevant. You could maybe omit all the ones that seem irrelevant and tell people run with a command line option to tell you all the things. I don't know. Right? But the point is that's, you know, that is one consequence to not having like add be a method on the object, for example, right? And we're just exploring that out. With this type variable way, I don't understand that part, of doing entities. What is the preferred way to do virtual? I mean, we don't, like, you don't ever, okay, here's the thing. Let me finish reading the question. What is the preferred way to do virtual functions? Simply a procedure pointer that you set on the declaration, or a meta-generated procedure that does if. I mean, I would do one or the other of those in different cases, usually just a procedure pointer on the declaration. But the thing is, this is a very rare thing to do, actually. Like if you're in an object-oriented mindset, like if you're used to programming in C++ forever, and then you come to a language like this, and you're like, okay, I'm just going to do things the way I normally would do it, you would end up trying to do a lot of virtual functions. The thing is, like again, what I was saying in the beginning is that if you want your code to run fast, you want to operate on batches of things at once. And that means that you kind of have a system that owns the code. The objects don't own the code. And the objects don't tell you at the last minute to go do a totally different thing than you thought you were going to do, right? And so what you end up writing in a game, well, okay, so speed is one reason, but also simplicity is it's just very easy to go into some linear code like here. Now we simulate all the stuff that we need to do for the frame. Here's the loop that goes and advances the time on all the animations. Here's the loop that updates the beams, the light beams, and like what they're hitting and all. It's very readable code. Whereas if it's all hidden away in like virtual functions, you can't tell what's going on, right? So there's lots of reasons just not to do things that way. And so when I write a game like this, we almost never do that. There are some cases in which we have something. So if I go to like particle source, right? We have some function pointers on here that you can set. There's a lot of things about particle source. Yeah, so you can set like a proc for like, actually these ones I didn't add. I probably wouldn't have done that way, but there's like a spawn proc, let me see, spawn proc, yeah. So you can set a proc on this that happens once per frame and one that happens when a particle spawns, although hopefully this one is null if you want to run fast, right? Or if you're not spawning that many things. So, but like of all the, you know, I forget how many entity types we have in this game. I should look. It's certainly more than 50 and maybe 100. Like we do almost zero of this because it's just not a very good pattern. It's not a very good way to program, honestly. Unless you actually specifically need that. Like the reason why this is useful here is because for the specific user of the code, we get a great deal of variety out of them being able to specify ways to modify particles after spawning. It's like how you even configure a particle system. And so there's a lot of utility that comes from that. Whereas in a lot of object-oriented programs, there's not really any utility. It's just, you know, we have this philosophy of structuring the code this way as opposed to this other way. And the utility is the same either way, right? Whereas this one, without the procedure pointer, you just wouldn't really be able to customize. I mean, obviously you could structure it differently, but like pretty much anything you do would be ugly. Whereas a lot of the alternatives to object methods are just more straightforward and more simple and more readable and faster. And so it's just not really a thing that I consider to be very important. How do you do object methods? Like they're just, you know, again, I've shipped multiple, actually, I'm kind of lying, because both Braid and the Witness were written in C++ and had, the entities had methods on them. But that was sort of more out of the habit of how you write C++ code. They were almost never virtual methods. They were just structured as methods, which is essentially the same as static functions. And so for this engine, it's like, well, there's just flat functions now. And yeah, that's just better. Are we looking for more example programs? Maybe. I mean, there's a question of how much stuff we should be giving out with the compiler. So I'm not sure that we necessarily need to like do a call for that kind of thing, but who knows? It's always fun to get the compiler downloaded and have cool things in there. So if it's cool enough, then maybe. Okay, people are asking more general questions that I'm gonna maybe skip. Is there a better way of catching up with what's been going on than going back and reading all the change logs? I don't really know. I don't provide a better way of catching up than that. Somebody else might that I don't know about. Okay, let me, I'm going to pop over to the Twitch. How's it going, Twitch people? Do we generate a syntax tree for the entire program or separate for each function file, etc.? I mean, depends what you mean. Because we do generate, basically we sort of treat function bodies and struct bodies and stuff like that as individual things. But they get linked from the global scope. So there's kind of, in some sense, a syntax tree of the whole program. But I don't think you would look at it that way. I think you would look at it as function header, function body, struct body, etc. How does assembly work? Is it based on x86 always? Like if ARM became more used, how do you handle running ARM apps? Yeah, well, right now we only have x86. The plan is to expand that to support ARM or whatever else. It just, that takes time. Oh no, I didn't do the, okay. I have to get some chai ice cream now because I advertised this. So in the last 10 minutes or whatever, it's going to be chai ice cream time. I knew I was forgetting something. Can I give beta to everyone in Twitch chat? I'm sure I could. All right. I have to let it like soften a little bit. My freezer is very cold. But look at that. Look at that chai ice cream. Let's get some camera here. We need the full disclosure of the chai ice cream. Okay. Great. You could boost in Tarkov for beta. I'm pretty sure they would ban you for that. Hit the ice cream. Is paid beta still in the works? I don't know. You know, the more I thought about it, the more I was like, is this really worth it? And I've sort of been concluding no. I just have too many things to do. It's probably like running a Kickstarter, but even worse. And I just don't, I don't need that right now. Is there a way to make beta access paid so people could contribute money-wise? I mean, small amounts of money don't matter is the problem. Like, there are amounts of money that would help us do things faster on the compiler. But those amounts are like $500,000, right? And like getting $500,000 out of a paid beta, that might happen. But then we also have all this extra stuff to do because it's a paid beta. You have, you know, very entitled Twitter users telling you to do things, and like I don't want that. So I don't know. So like if anybody rich wants to donate to a programming language research project, we would gladly do that. But you know, why do I dislike smart pointers? For all the reasons that I already said today. Apply those to smart pointers. That's a question that I've ranted about so many times that I don't want to subject people to it again, basically. So otherwise I would answer the question, but I've just given this rant so many times. And I'm guessing that because you know I do not like smart pointers, that you've seen the rant. How else would you know that I don't like smart pointers? Do I think Steam OS will lead to consoles becoming commodified? What? What is Sony's value add when any Linux box can run any game? I mean, what is Sony's value add when any Windows machine can run any game? Like, what do you even mean? Can I explain how import works? I mean, I already kind of explained it. It creates a module where a module has a separate global scope than the main program, and that gets populated, and then things that are exported from that module get linked back into your scope. I'm sure there's a stream where I like do this. Are LSPs important? No, I gave an entire speech about how LSPs are fucking stupid. The ice cream is getting softer. How does calling OpenGL from an interpreted language work? This is not an interpreted language. Well, the compile time execution sort of is, I guess. Do you embed OpenGL into the VM? No. So we use... this helped us get off the ground. We would be able to remove it if we wanted to, but there's a... we use this library called libdynecall, which basically, I don't remember where's the actual, Anyway, it's an API that will handle calling into, okay, how do I explain this? So if you're in C and you have a header file for some function, obviously you just call the function normally, right? If you have the pointer to the function, but the compiler doesn't know it at compile time, and you want to call the function with arguments, well, there's two things you could do. If you happen to know all the arguments, you could just, use a function pointer in C, right? That's what those are for. If you don't even know the argument types at compile time, that's where this comes in, is it'll, you give it declarations of like what the argument types and all that are at runtime, and it sets up the call for you. And get all functions check if the module has been initialized to a hash table. Isn't this a bit bug prone and potentially slow? Well, isn't it bug prone to require people to initialize things before using them? Maybe. When using LLVM backend with optimizations, does any of the undefined behavior nonsense need to be considered? So far, I've just been ignoring it. Like, I do know that there is such a thing as UB in LLVM, but I'm not even sure what it is. Long term, I consider LLVM to be ideologically compromised, so it's not ever going to be like the basis of the compiler's code generation. It'll always just be an extra thing that we use to target platforms that we don't directly support or whatever. But yeah, so far in practical terms, any UB that LLVM has not been strictly a problem for us. Yet, maybe. Who knows? The biggest problem is how slow it is. The biggest problem is how undocumented it is. The second biggest problem is how slow it is. Did the LLVM update end successfully? Well, the thing that happened is it is tied together with some other issues, because the newer LLVM, is it 15 or 16? I think it's 15. I don't remember. It is very, very slow with data segments that contain a lot of pointers, which we have. And so some of the relative pointer stuff that Raphael was working on was about, let's just, hey, if these are relative pointers, they don't count as pointers. And so LLVM will not be as slow. But that looks like it's not going to work out. So we might have to hack LLVM or something. I don't know. 15. Yeah, so he's here in chat. He can give you much more detailed information about this than me, because I only was a bystander to this particular thing. Is x64 backend generated from a custom intermediate representation? Well, we have an intermediate representation that we use for everything, including runtime or compile time execution. So yeah, would I consider SSA a good idea on intermediate representations? I don't know. Here's the thing. Okay, first of all, most explanations that you see about SSA are too complicated. anything that's telling you about like fee functions and all that stuff is not good. And also, and the reason it's not good is because it's much easier to conceptualize what is happening with a fee function in the other direction. If you just think about parameters being passed to basic blocks, right? Another thing about SSA is that most of what you will see out there about how to generate SSA is also overcomplicated BS, because you actually know most of the structure of the data flow, or maybe all of it, just when you do your regular code generation. Like you see all these things where they like start with, you know, some kind of bytecode instructions or something, and then do analysis to create basic blocks, and then, you know, blah, 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 do all this splitting and merging and stuff. And it's like, no, you actually know all that information statically. We actually do a bunch of that right now, even though we don't really use it because it was sort of on the roadmap to doing more serious data flow analysis. In terms of why you want SSA, it does make certain kinds of things a lot easier. Like so SSA stands for single static assignment, or static single assignment, one of those. Which just means you only ever assign to a variable once. And the advantage of that is that now when you're doing optimizations or any other kind of like code manipulations, you don't have to worry about like, is this manipulation going to be correct, or is the value of this variable going to like, you know, change later? It's like, no, anywhere where the variable is defined, it has the same value, and you just don't have to worry about a bunch of stuff. It really does simplify a lot of things. The question is, how much complication do you buy into to get that? And I don't know, because we haven't like converted. We don't do SSA internally right now. It's unclear whether we should. And we're just wondering whether it could be a language feature meta program which makes these APIs less bug prone to write. I mean, maybe. The thing is, how does it know where to insert things? You kind of have to mark it up, and then if you have to mark it up, then a one-line macro at the beginning is approximately minimal markup anyway. It could be like maybe every function, like if you had some more elaborate situation, like every function between here and here is an entry point, and therefore all entry points will get marked up, then that's fine. But then what happens when somebody isn't thinking about that and like defines a helper function? I don't know. Like, it's just, sometimes things aren't completely clear. Like usually if things are completely clear how you do the awesome good version of something, I just go ahead and do it, right? So usually when I haven't gone ahead and just done it, there's reasons like this where it's like, well, it could be this way, it could be that way. Any book on programming I learned from? No. I mean, I read a bunch of programming books, like literally in the 80s and 90s, but none of them would really be relevant today. And honestly, none of them were all that good. So, you know. Actually, the best programming books I had were the ones from Radio Shack, where you would go through exercises on your TRS-80 computer. Those were pretty good. I don't remember what those were called. Was the LSP talk I was referencing segment in preventing the collapse of civilization? Yes. Yes. Yeah, so the compiler got slower recently. Someone's asking about speed. Let's see what it is here again. I know we had some command. There we go. Let's just see what we get. We're streaming, so it's always slower when we stream. Actually, that's true. It wasn't apples to apples even when we compared against the other laptop. But so, you know, we have 265,000 lines in 1.5 seconds, right? Not counting the linker, which we have no control over right now. And so we're at about, on this laptop, about 175,000 lines per second. On the other laptop, it's around 150. If we weren't streaming, it would be more. We were at 250 on computers slower than this one, and we took a little bit of a nosedive in performance. The long-term goal is a minimum of 1 million lines per second. To get there, though, we need to parallelize the compiler, which is hard. But yeah, we were at 250,000 lines per second at one point, and then I made some changes, and they were seemingly not the best. Write my own programming book. I mean, I just have too much going on, folks. Oh, we've got more questions in the official. Let's see. I think it's time to wind down soon, but we'll do a couple more. And see, you can create a mutable array of characters on the stack. Yeah, you can. You can have an array of characters. That's fine. Like it's important just to understand the difference. Like a string is not an array of characters in this language, right? So if you're used to thinking about it that way, it's not. It is a pointer to an array of characters with a length. So as soon as you're just because if you're just hand waving in your mind and you're like, I don't know, a string is like some data, then it's easy to be confused about these things. But if you're like, oh, it points at some data somewhere, then it's very clear, right? Okay, I think this is going to be it for the stream. Dude, yeah, I don't even understand what you're saying about Ellis. You'd counterpoint with some code bases are just so large they need services like FB Watchman. I don't know what FB Watchman is. I doubt it is better than what we do. So I'm not sure why you're claiming you need a server for that. Do I have any tips for working on a software project at a college with people who don't really know what they were doing? Yes. Drop out of that group and find people who know what they were doing. All right. Thanks. We'll probably put this on YouTube at some point if you missed parts of it. And then, I don't know. It is what it is. Thanks, everybody. See you later on.